Anyway, good morning, and thanks for all coming on these kind of un-Florida-like morning. My purpose today is a basic introduction to DCC. What it is, what it can do, what it doesn't do. You need to know the basics before you can jump into all these other things, and that's my whole purpose today. I'm not sure what the level of knowledge or education is among folks with DCC, and if I'm talking way below your knowledge level, just bear with me. We're going to have another class down the road some ways on, I guess you could say, advanced DCC, getting into programming and mapping function numbers and configuration variables and all that scary stuff, which I don't even like. But first thing with DCC is to understand what it is and where it started from. And they're just DC, direct current. That's old school, a regular transformer, like we've all seen for eons, 0 to about 14 volts. The more you turn the throttle up, the faster the train goes. You reverse the polarity, and the train goes in the other direction. Then now we've got, oops, I like the CO. That's DCC compatible. That means the engine can have DCC installed in it. Not necessarily ready for it, that means it's ready to be wired. An engine such as this here, like these that say DCC ready. Most engines are like this. They mean what they say. There are some out there that don't actually. What this means is there's a plug inside. You get your decoder and it plugs in. The engine is now able to operate off of DCC. Then you have, as an example, this one here, DCC on board. It has a decoder in it. There's two kinds of decoders. This one here has what's called a motor decoder. It takes care of motor functions, forward and backwards, speed, and lighting effects. No sound. Then you have DCC, last one, DCC and sound. That's the one that does everything. And so when you're shopping for an engine, make sure you get what you want. And depending upon what you're looking for. You're going to install it yourself. If you want it ready to pull out of the box and set it on the track, make a big difference in what you're doing. Just very quickly, without getting lost in heavy electronics, the difference in DC and DCC. I've told people in the past, DCC, you have 14 volts AC on the track at all time. I was corrected not too long ago when I did a little bit of research. It's not AC current. It's actually a pulse modulated square wave. You don't have to remember that. A alternating current is what they call a sine wave, like what comes out of the outlet in the wall, and the current goes like this. DC, direct current, it's a constant line. When you reverse the polarity, it's below the line, it's down here. DCC, it's a melding of the two. That's why they call it a square wave, because it'll go like this. And what's happening is it's reversing polarity constantly in milliseconds. Each one of these pulses is a signal from the controller telling the engine what to do. That's why a DC engine doesn't like the DCC throttle, because it wants this pure current, and what it's getting is this and this and this, and it just sits there and buzzes at you. That's why you can't run a plain DC engine on a DCC throttle. You can the other way, but not like this here. So I just, if you understand what's going on, it'll make it a little easier on why it works or why it doesn't work. We'll take just an example here, again, of the different engines. This one here, DC ready engine. So in other words, it's DC power. And it responds immediately to the throttle. Reverse it, goes in the other direction. Then you have DCC on board. There's an actual decoder in here. You try to run it, it's DCC, it will run on a DC throttle. It doesn't run quite as well. The throttle is almost up full on it. That's why when they say it'll run on DC, yeah, it will. But you've got to get it up to like 7 to 10 volts before the engine will move. Whereas on pure DC engine, it'll start moving at just a couple of volts. And then you have your, it's anxious. Start it up as soon as I take the track. This is a locomotive by Intermountain. Got the full sound effect. As soon as power is applied, the diesel engine goes through a startup cycle, starts running, and then it sits there and idles. Occasionally you hear a spitter valve go off or a compressor, just like the real locomotive. It's got all the full lighting effects. With a horn, and a bell. And like the real thing, the engine notches up, and then it starts to move. It absolutely simulates what a real diesel locomotive sounds like and operates like. And because I'm going in reverse, the light's on in that direction. That's the other thing you get with DCC, is constant lighting and reversible lighting. The light will come on in the direction it's supposed to go. Some of the locomotives will have what they call Rule 17 lighting. The light will dim on the other side. And you can also hit a button to dim it on an approaching train. So you can simulate all the things that the real locomotive will do. And we'll get into this in just a minute, but to show you the difference between sound and no sound. There, it's like it just died. And obviously it's running because the motor is still going. But the difference is tremendous once you bring the sound back and the whole thing comes alive. Now the other leave him sitting right there for a second. So just to go back a little bit, I ran through a bunch of things there at once. Standard DC power pack will run a DC engine. It will run a DCC engine, but not all that well. If it's a DCC sound engine, I'm up to almost full throttle right now to get the engine to start. Plus you have no control of the bell, the whistle, or any of the other sound effects. You go to DCC, you can run all your DCC engines, but you cannot run a DC locomotive. So if you're in the process of converting, what you want to do, you've got to make a decision on either separating a portion of your layout for the DC locomotives or get into actually converting them. Like myself, I've got way too many locomotives than I should have, and they're all DC. Kind of a monumental task. If you're just kind of getting started, you've only got a few, it's not that bad. You can have decoders. Simple as that right there. About $18, $19. That's the actual board right there, and there's your little 8-pin plug. This locomotive here that was labeled DCC ready, this plugs in. Now you've got a DCC locomotive, and many locomotives, it's as simple as that to convert. So it's not a big monetary cost, and it's not a whole lot of wiring and soldering and all this business. Even if you have to do that, there's 9 wires on here, but basically you only need 4. I can pull them out here. And this is the same on every DCC locomotive. The black and the red from the decoder goes to your wheels, your pickup. As the locomotive paints forward, red is always on the right. All locomotives are wired the same way, that way all locomotives will move in the same direction. The orange and the gray, right there, whatever, you can't see them from here anyway. The orange and the gray go to the motor. And the motor is isolated from the frame. So the only way the motor gets power is through the decoder. Those are the only 4 you need for it to work. The other wires are for lighting. Front light, back light, ditch lights, like that one there has got a set of ditch lights and everything. So if you want to wire up all that, you can, but the 4 wires is really all you need to make the locomotive operate on DCC. 2 to the track, 2 to the motor. And then follow the color coding. The color coding, just as a sidelight again, DCC started, I think it was 1964, was the first time somebody came up with a remotely operating a locomotive on a system. And then a number of systems came out. Dynatrol, Astrac was a big one. And they all had different systems, and everyone started doing different things. Somewhere in the, I think it was the late 60s or early 70s, the NMRA, the National Model Railroad Association, put a group together and decided to set standards for DCC. Took them a little while, and a little coaxing and conjuring, and they came up with a set of standards so that in HO and N gauge, every DCC locomotive can be operated by anybody else's DCC throttle. They're all interchangeable. So that the whole market was in wide open. It was sort of universal technology. What do they call it? Universal technology. It goes on the web and it's available to everybody. And that's why oftentimes you'll see NMRA compatible or NMRA approved, such like that, because it meets the standards. One of those standards being the colors of the wires. So no matter what locomotive you got, no matter what decoder you've got, you know the red wire is going to go to the right-hand wheel, the black one to the left-hand wheel, and it'll hook up the same. O gauge, they haven't done that. Everyone is doing their own proprietary system, and sometimes they work together, sometimes they don't. But if you're in HO and N, you've got the benefit of the NMRA for the last 25 years setting the standards so that everything works together nicely. And to the best of my knowledge, every single manufacturer out there today follows those standards, at least for the sales of equipment in the United States. They got a few different ones in Europe. Yeah.
So when it's DCC ready, you just take the cab off, and then there's a male-female connection there?
That is, Atherton is like that. Some of the other manufacturers, I think Bachmann is putting the plugs in now also. Some of them in the past, they say DCC ready. What they're saying is it's ready for you to wire, not ready to plug in. For the most part, the major manufacturers are like that. They've got the female plug and this pops right in. Just got to make sure it's oriented correctly. Yeah.
Jack, I run mostly steam engines, so is that going to work out the same? Because I see things sometimes in articles about the revolution of the wheels matching and things like
There's
that.
the old way of matching or getting the sound to match the revolution of the wheels. There's 4 chuffs per 360-degree rotation of a drive wheel, when it is 2 on this side and 2 on that side. They used to do it by a mechanical wiper on the back side of the drive wheel. You paint insulated paint, leave a spot, 90 degrees, leave a spot. There's a little brass or bronze wire wiper that would pick it up and that'd go to the board so that it could time it. They don't do that anymore. The electronics have become so sophisticated that the board knows the revolution of the wheels, and at times the exhaust chuck coming out of the sound system. Now, sometimes you'll have a locomotive that is slightly off, but on all your controllers, using the buttons down here, you can go into what they call the CVs, or configuration variables, and you can adjust the timing of the chucks to match the movement of the wheels. You can adjust the exhaust, what's called a cutoff. I believe there is, basically I think there's like 27 or 28 different things that you've got, in general, you've got control over. Some of the systems have got far more than that, but you're really getting into the weeds on some of that stuff. Steam locomotives are a little more involved than a diesel. I've been talking basically about diesels right here. Which kind of brings into, when you say a steam locomotive, older engines, especially back into the 70s, basically you can convert any locomotive to DCC. It's just depending upon the amount of work that you want to invest in it. The old way of doing the motors, especially in the steam locomotive, is that the motor was mounted solidly to the frame. And that was one side of your circuit. That went to the wheel on the left side generally, and then you picked up one contact of the motor. The other one went to an insulated wire back through the tender and picked up the tender on the right side. You can't do that with DCC, because the motor has got to be insulated from the track. Because if the motor's connected to the track, you're going to get full square wave, I forget, the pulse modulated wave, and it won't work. The power to the motor has got to come through the board. That way you can't have the motor attached to the frame. So older locomotives that are like that, you've got to take the motor out, put some kind of an insulating pad in, or use, what do they use, acrylic caulk, adhesive caulk, to make a bed to set the motor in. It helps the noise level too a little bit to get that done. Older diesels, especially in N scale, are the same way. They'll have a split frame with a motor mounted across the top, and it picks up power from each side. Can't do that. You've got to insulate that motor from that split frame and then take leads off to the board. So when you're dealing with older locomotives, yes, you're going to get into having to hardwire them. But again, if you just remember the same basic things, 4 wires, 2 from the track to the board, and 2 from the motor to the board, and don't have that connected to anything else, and this board is isolated. You don't want to set it down like that where some of the contacts may touch part of the frame versus up where the motor, that would then short it out. Which, another side light, short circuits are the death of these things generally. The new decoders that are coming out, the factory ones and locomotives and such, have got some excellent protection in them against short circuits. A short circuit will stop everything dead. But as soon as the short is removed, it'll reset. This comes back up, the locomotive will be ready to go again. It used to be if you had a short, all of a sudden you saw a little puff of smoke come out of the engine, and it wasn't from a smoke generator.
I had one of
And
those.
you look at the board inside, it was half curled, it was all black in the center. Yep, that's it, throw it away. Fortunately, the decoders are cheaper now. But if you deal with the new equipment and the newer decoders, you'll have that protection to save it from a short circuit. They actually, in wiring, they use a short circuit on a reverse loop. Because even though it's not true DC, when you go into reverse loop, if you've done regular track work, you know you come out, you got a short circuit when you come out of the reverse loop. So you got to reverse it while it's in there. There's a little mechanism that you can buy called an AR1. When the locomotive goes in, it comes around and it touches across that insulated rail joint, there's a short circuit. But it is the AR1 detector that you use is so fast, it's faster to change the polarity than the short circuit causing a problem in the board. It's literally like nanoseconds. Again, I'm getting off into the weeds a little bit. Going back, we were starting to talk about the track and the wheels and such like that.
The decoder do you have to match it to the diesel as the sound? And
Yeah, there's
things
all
like
kinds of
that?
different sound.
I have a Flying Yankee, it's got a Winton engine, and they can't match
No,
that.
no, and there are no recordings of a Winton engine in existence. I know, I've got a Flying Yankee train also. And it's been found that there hasn't been a Winton engine running in 75 years, I guess. No one has got a recording of it, so nobody knows what it really sounds like to make a chip. The only ones that are available is you can use a sound chip for an early 1930s vintage EMD engine. They say that's the closest thing to what they supposedly sounded like. I'm sorry, went off. Said Flying Yankee, Winton engines, that's my specialty.
But it's a different, that's, I was just trying
Yes,
to the basic question, it's, do you have to match the
Yes, you
decoder
should.
with the engine?
When you start getting into getting sound chips, for your you buy it from the factory, the sound is appropriate for what the engine is. This is an EMD 710, I believe, engine, and that's the sound from it. They actually go and they digitally record the locomotives, and then they put it on a loop, little bits that is stored in the chip on the decoder, and that plays that constantly. But if it's an early EMD, you need an EMD 567 diesel. If it's an Alco, you need an Alco 244 diesel engine. And the manufacturers make all of these different sounds. On a steam locomotive, you've got a regular steam locomotive, you know, like a 462. It's got 6 drive wheels, single set of cylinders. You've got an articulated, you've got 2 engines, 2 sets of cylinders, 2 sets of drivers, and they kind of go in and out of sync. So that's a different sound chip. So you need a sound chip for an articulated. They've even got some where you can buy now, and it's the sound, like for the Union Pacific 844. Well, they just restored for the excursion service on the Union Pacific. Well, there's a sound chip that is of that engine that's running right now. So you can get as specific as you want. A lot of people don't care. Sounds like a diesel is a diesel. You become a little more into it, you know that, all right, that's an EMD, or that's a late EMD, that's an Alpha, that's a Baldwin, that's a Fairbanks Morse. But if you want to get particular, you can get the chip to suit the engine you want. There's a company called ESU Loc Sound. They're from Germany. Very, very high quality. This sound system here is Loc Sound. They throw all the little, pardon the pun, bells and whistles in, all the little background sounds, the ambient noises that a locomotive makes. They are now selling blank sound decoders. It's a full-blown sound decoder to put in your locomotive. You then, you have to get a little programmer. You take the chip, you plug it into the programmer, USB cable into your computer. You go to their website, you go through and you find the locomotive you want. The exact locomotive. It'll download the sound into the chip. Now you've got exactly what you want. The technology is evolving so fast, it's phenomenal. This is like the short circuits. 5 years ago was a problem everyone had to put up with. You had to be careful. You burn your things up and you're constantly putting new chips in. Now today, with the new protections that are on board, you don't have to worry about that as much. They've also, another thing, DCC locomotives are prone to having a problem with dirty track and certain switches in the track. I mean, you can fix that with simple things like, you know, keeping your track clean. As simple as $8 for the Walters brake plate. This here from KD, hook it to the track. You set the wheels of the locomotive on like this, and the brass brush cleans the wheels. Keep the engines and the track clean, you eliminate 90% of your problems. The other thing, a little thing that I wrote down in my notes, which I'm not even using now. DCC will not make a poor locomotive run better. I know at first that sounds like an obvious statement, but some people think they put this decoder in that's so fantastic, it's going to make this engine run kind of bulky, it's going to make it run smooth. No. That engine running kind of bulky is a mechanical issue, either with the gears or a motor that cogs. And DCC is not gonna help that. So, if you're gonna put DCC in a locomotive, make sure it's mechanically sound first and runs smooth. Because otherwise, you're just gonna have a poor running engine that runs on a DCC throttle rather than a DC transformer. Yeah, and that's the other thing on a layout. DCC will not correct existing problems on your layout. If you've got problems with track work, whether there's a dead spot here, dead spot there, or bad switch, DCC is not going to fix that. You've got to make sure that your track is good. Even if you're only going to operate DC, you need good track, good electrical contact throughout the whole system for it to run well. You say DCC is not going to fix that if you've got those problems. It's not a miracle worker in that respect. Now, they have developed something in the last year or two called, I think NCE calls it Stay Alive. On board the engine, besides your decoder and everything, there's a very large capacitor. I don't know if you know anything about electrical. A capacitor stores electricity for whenever you need it. And what they've got now is that if you do run across a dead spot in the track, the power from the rail to the engine, the decoder says, oh, no power, kicks in the capacitor to keep it running. It stays alive until it picks up power from the rail again, then it cuts it off and goes back to charging the capacitor, so it's ready for the next time. But somebody pointed out that's wonderful, except if when the capacitor is providing power to run the train and the sound and all of that, that means it's not getting its power through the rail, which means it's also not getting the command signals from your throttle. So you cannot tell it to slow down or stop. So, and these capacitors will make a train run, some of them, they'll go 10, 12 feet on the power that's stored in that capacitor. So if you're heading down a dead-end track and you've lost control, again, you've lost control, you're going to lose your engine because it's going to go off the side or wherever. Again, so you go back to, yes, the Stay Alive is great for a little short section so it doesn't stutter, but don't rely on it to take care of bad track work. That if you've got a broken rail joint and the power doesn't go through. Let's stop for a moment. Am I rambling on too fast here? Everyone caught up? Talking track work to run with DCC, one of the big points on DCC that they've always talked about is it eliminates all the wiring. Well, it can, to a point. My layout at home, I've got, I think it's 32 blocks. And I've got rotary switches to control every one of them for the DC power. I convert over to DCC, I just turn all the blocks on and hook up the throttle, and then you run the whole layout. If you got a smaller layout, like a 4x8 or something like that, you just hook up 2 wires to the track, you're good to go. That's it. You don't need anything else. In that respect, yeah, it does eliminate wiring tremendously. If you got something larger than that, and say you've got a main line over here, yeah, I'm sorry.
Do you have to set it up in blocks?
No, you do not. I'm going to get to that. I mean, you can have the whole layout in a smaller layout, like a 4x8. The whole layout is a single block. Because the thing is about DCC, each locomotive has got its own address, its own ID. This one is 713. This one is 815. You program in the number of the locomotive in your throttle. So you put 3 DCC locomotives on the track, you turn the throttle on, nothing moves. You address 713, 713 will move, the other 2 will just sit there. So you can have this layout with 24 locomotives. You turn the throttle, just talk to that one, that's the only one that's going to move. That allows you, by talking to each locomotive individually, you can put 2 or 3 engines together and do what they call consisting. You're going to put the 3 into a consist, and you give that consist a number, like consist number 1. You tell it it's engine 2163, 815, and 713. Now they'll all run together. And you can speed match them so they don't fight with each other. That's kind of getting into the the fancy programming, as I call it. Yeah,
Can you run an N gauge as well as an HO gauge, or do you have to have the same gauges to
No,
run
no.
off of one DCC?
you can run it all on the same throttle. I mean, the electronics and everything doesn't know what the gauge is. It's just sending commands over the power supply to the rail. That's all it is. So it doesn't, well, even in O gauge, there is what they call, this track right here, 2-rail O gauge. And those run on, can run on DCC also. It doesn't matter, the only thing you can't run these DCC throttles operate is 3-rail, you know, the old Lionel, for like the fast track out there in a big layout in the store. Lionel and MTH have got their own systems for doing that, because that power is AC on the track. So they've got their own systems and they're off on their own. And if anyone wants to know more about that, we can talk about that separately, but that'd be getting too far off track. I think everyone we're talking to here right now is 2-rail, HO or N gauge, right? Yeah. Speaking off track, I've derailed there now. Back to the track work. So the stay alive things, yes, they're great, but be careful of them. Rely on having good track, so you don't have to rely on those electronics that could get you in trouble. The other thing with track work is the equipment, again, that you use. The older equipment, now there's a wheel set out of a locomotive. It's a 40-inch wheel. The width of the tread, right here, of the wheel, older trains, that wheel tread is wider than what you generally find on equipment today, or models today. The flange, which is this little piece right here, is a little deeper and thicker in the older trains. What can happen is that on a switch in the track, where the rails come together, I like my whiteboard, but it's too low here.
Jack,
Yep.
when you're right on that side, so I can film it.
A switch in the track. There's your 2 rails. There's your switch. The 2 rails coming off like that. In this point right here, most switches, Atlas switches, the Pico Insel Frogs, Bachmann switches, this is plastic in here. It's insulated so that you don't have a short circuit. Now, this is plus, this is minus, plus, minus, so you get plus and minus, you have a short circuit right there, so that's why it's plastic. But these wider wheel sets, when they come through here, it'll bridge right across there. And you have a short circuit, boom, everything stops dead. So again, they talk about DCC friendly switches. What they do in a DCC friendly switch is that this becomes all metal. They have put insulated rail joints here, and the points are all separated. And you have contacts underneath the switch. That becomes a project in and of itself, doing all of that. If you just make sure that you don't have these wider wheel sets on the older equipment, like I'm talking like 70s vintage, 60s vintage equipment, locomotives especially, older locomotives. They'll bridge that joint right there, or right in here, it'll bridge across those 2, and that'll short out. But again, if it's the older equipment, yes. If it's newer equipment, the last 15 years or so, it won't. So it's an issue. It probably won't occur, but you should be aware of it. As far as that, if you're having a problem, you can always write in here, where these come close, you can take some paint, or clear coat, dull coat, something like that, and paint the rail back slightly on the top, on either side like that, to extend the insulated part a little bit further, so it doesn't short out. All right. The other thing with track is what they call a reverse loop. And we kind of touched on that before, and I saw a lot of blank faces.
One thing I've been wondering about.
Um,
They work.
So what you've got here, you see all right there?
Yeah, I believe.
Train comes in a reverse loop, comes around, back in the other direction. Now, again, your polarity. That's plus, there's minus. The outside rail is positive, comes around to here, now you got a short circuit. So what you have to do is put insulated rail joints on the loop. You should have this piece of track here in the loop longer than the longest train you're going to operate. If you're going to have like passenger cars with lighting in them or lighted caboose, such like that. If everything behind the locomotive is insulated, you don't have to worry about it. You got to have at least longer than whatever combination of locomotives you've got. What you then do is that you have what they call a double pole, double throw switch, like I've got right here that I've been using, switching back and forth. The train goes in, and while it's in here, you flip this switch and it changes the polarity so that it'll flow right back out. And people say, well, the train's in here and you throw the switch, why doesn't the train go in the opposite direction? Because in a DCC, the mind of the DCC decoder, the track power does not change the polarity of the locomotive because of that square wave you're getting. The decoder changes the polarity. So you can provide power to the decoder this way or this way, and it's still going to go in the same direction. I know, I still, having talked to people about it, I still have a hard time wrapping my mind around it. We're used to the old conventional direct current, where you throw the switch and you change the polarity. But because of the type of electricity that's on the track, it's the decoder that changes the direction of the motor, which direction it's going to run in. But what you're doing by throwing the switch for the track here, this changes this from plus and minus to minus and plus, so that it'll flow out correctly without a short circuit at this point right here.
So are you changing what's inside the loop?
You're changing inside the loop, correct?
Okay, so not outside.
Not outside, no, because if you change outside, you may run into a problem with whatever's out there. But the main thing is that you're just changing to prevent this short circuit. Now, this is using a toggle switch. That's about as low key and as traditional basic as you can get, as cheap as you can get. They've got electronic modules that you can hook up,
Yeah.
which when the train comes around, like I was saying before, at this point, it feels that short circuit as soon as the wheel crosses the gap, bam, changes the polarity instantly so that it'll keep right on going. And I have a hard time wrapping my mind around that also, but I've done it, I've seen it work, it works. A lot of DCC, this is kind of an odd way to put this, you just got to take faith that it works, because it does. If you try to think it out too much, you're going to get in trouble. Like this right here. It's thinking old school electricity. This does not make any sense at all. But because of the type of electricity that they're using, it's not AC, it's not DC. And the fact that it's the decoder that changes the polarity to the motor. See, again, that's why I said the motor is going to be totally isolated from the frame and the wheels where the power comes in. So it doesn't matter what's coming in. The decoder knows that the engine's traveling in this direction. The right-hand side is the red wire, and it's going to provide the polarity to go in that direction, despite whatever's coming into it. until you send a digital command to the decoder, go in the other direction. Then it changes. Because the motor in these locomotives is still a DC motor. There's an actual little inverter on the decoder that changes the polarity, or changes it to a DC current to the motor. That way it can be switched to make the motor run in the opposite direction. And after you say it enough times, like I say, you'll have faith and you'll believe it. It does work.
I've got two
Electronically?
on my- I've got 2 reverse loops.
Okay, so each one will be separate.
But I had a spur that I had wired in the wrong place in the loop.
Uh-oh.
So I could never figure out why that reverse loop wouldn't work. And one day I was under the layout, and I said, well, let's start from scratch. And I cut out that spur.
And then it
thing
worked.
perfectly after that.
Sometimes you'll find issues like that, and you'll do something and it fixes it. And you just say, thank you, Lord, and go on. Don't try to figure out what you did, because then you'll try to start doing other things, and then you get in more trouble. You've all heard the term plug and play. So much of this stuff is plug and play, like the AR1 thing. Hook 2 wires here, hook 2 wires on the other side of the insulator, put in the joints, and it works. Don't worry about how it works, it works. The same as what goes on in the decoder inside that engine. There's all sorts of black magic that goes on inside there. I know it works, that's all I care about. Now, the other thing you were saying about blocks, separating the layout into blocks. Your average size 4x8 layout, you know, up to whatever, 6x10 or 12. 1 block is good. You start getting a larger layout, you've got a double track main line, and you've got a yard over here, you've got a yard over there, and a switching area. Old terminology is you will divide the layout into blocks. The new terminology is you divide it into power districts. It's like everything else in today's world. You got to relabel everything. I might just roll this back in. I guess this is sad. I'm starting to feel like Karl Rove with my whiteboard. There it is. All a power district is going to do is, say you've got a layout, whatever like this, and there's a yard in here, and there's a yard here with sidings and everything. You will take and, well, I put a reverse loop in there, let's not complicate matters here. Say we've got another line that goes up and over, comes in like that. Take maybe the main line, separate it here. This here is 1 power district. The yard in here is another power district. The yard here is another power district. The purpose for that being is that if you're operating down here in this yard, you're switching, and you've got a train running over here, and you've got another train running over there, and something happens, a train derails in the yard, it bridges the rails and it shorts out, it doesn't stop the whole railroad. It'll only stop from here to here. The trains out here will keep on running. That's the sole purpose of it. All this, I didn't bring one up. NCE makes a little board about this big. It's got 6, actually they're like light bulbs. And your 2 wires from your throttle go to this end, and there's 6 pairs that go up, 1 to each one of however many power districts you need. If it blows, you just replace the bulb. Or at the very least, it'll come on, it'll stop, and the light will come on, you know there's a problem in that power district. If you're running down here and it goes out, well, where is it? The board will tell you it's back here. And that power district 2 or 6 or whatever it is that how you've got it set up. That's the only way you would need power blocks per se, or separating it, is in a larger layout where you want to separate one area from another in case of a derailment. And a derailment going to more than likely happen in a yard where you're switching, pushing cars back and forth. And like the new wheel sets, no, they won't bridge through the frog or between the points. But on a piece of track, if you have a derailment and it's a metal wheel set, it can cross over and derail, that'll cause a short. Especially in a steam locomotive with a pilot truck and a trailing truck, there's a lot going on there. One of those comes off, you're gonna get a short. So this way it controls things a little better for you. And keep the trains running on time. And I guess I'm gonna have to back up and consult my notes here.
If you're running more than one locomotive at a time on a layout in different power districts, you need an individual throttle for each of those locomotives.
No. Everything from the throttle still goes through for the whole layout. It's just that there's that fuse, so to speak, or circuit breaker into each section, so that if you can run a train across the whole layout still with the one throttle. If the one blows, you can still run elsewhere.
That's not exactly what I meant. Say you wanted to run two locomotives at the same time, as individuals,
Right,
all done through one throttle.
right,
So you're controlling both locomotives at the same time through one throttle.
right. And that's probably my fault. Let's back up to this throttle. This is the NCE, their basic throttle set. That's one of the tall boxes sitting over there. If you don't have DCC now, you get this here, you get your cable. This goes on the side of the layout like it is right here. Plugged in right there. This is plugged in there. On the back side of it, the wall outlet plugs in here, and two wires from here to the track. That's all there is to it. Now, when you, well, you can't see right here, but on the display, it says LOC for locomotive. Right now it says 003. That locomotive is 003. When you buy a DCC engine, they all have the default address of 3. So that's why that's set up right there now. And it says REV. It's currently in reverse. Get direction. Now it says FWD for forward. And there's the time, which is like trying to set the time on a VCR 20 years ago. Haven't figured it out yet. Down here, this display panel, right now it says L. That means the light is on. And then if you hit other functions, the numbers will come up there to show you what you're doing. Now, that being said, to talk to that locomotive, right there, select loco. And the other systems, Digitrax, MRC Prodigy, Lens, Bachmann, Dynatrol, or not Dynatrol, DCC Easy, they're all the same, just different configurations, but it's the same thing. Select loco, 3, enter. Now this is talking to that engine. You set the speed and it starts running. Now I want to talk to this one. So I hit select loco, whatever, 2163, enter. That one's going to keep running where I left it. Now I'm talking to this one and I'm controlling it. So I get it started. Then, recall, hit recall. It'll bounce back to 3. Now I can control that and stop it. Hit recall again, it bounces back to this one, then I can bring that one and stop it. This basic system has got a 2 amp capacity. They say it'll run 4 to 6 trains. The newer locomotives, they'll draw 1/4 amp. Top end speed with sound and everything, they might push a 1/2 amp. That's what they're using as a big 2 amps divided by 4, 1/2 amp each. The sound locomotives draw more current because there's more going on inside with the amplifiers and the sound generators and the speakers and everything. So you can, using their standards and your manual dexterity and mental acuity, you can get 4 trains running in Chile at the same time, run it from this. You've just got to toggle back and forth using that recall button. And then the big red button in the middle, that's your friend. You hit that, everything stops. Now you can go beyond that. That box over there says SB5, the second tallest box. That's a booster. SB, it's a smart booster. That plugs into here, and you pull the other power supply out. What that does, that boosts us up to 5 amps now. So now you can run like 10 trains at the same time. Yep.
Before we get too far, I just want to make sure that you could run those two individual trains in any power district.
In any power district.
Okay.
The power district is simply for the matter of protection against short circuits. Other than that, it's still one homogeneous layout. So with the SP5, you have the 10 amps, you can run, or 5 amps, you can run up to 10 trains. Plus, it's got the ability that right now, when you're running this train, you pull the plug out, the train stops dead. With the booster, you pull the plug out, the engine keeps going. All of them keep going at the speed you left them at. You can walk further down around the corner, plug this in, and you then pick up control again. So if you trip on the way, you might have some major accidents with 10 trains running at the
Now
same
you've got
time.
wireless on those things.
Yeah, then beyond that, they've got, throttle looks just like this, only it's wireless. So you can go in, with the NCE system, it's RF, it's radio frequency controlled. The Bachmann Dynamis wireless control is infrared line of sight, which means your throttle is going to be pointed at the receiver to control the train. So if I start talking to you and I go like this, it loses signal and the train stops. So again, if you're looking at your wireless system, it's best to go with an RF system, not an infrared. And I think the ESU Loc sound is infrared also.
Isn't it correct that NCE will convert your unit to wireless for you if you send it to them?
I haven't heard that specifically. It seems to me that that sounds like a logical thing. It's a matter they open the case and they put a couple more chips in it and that's it. Yeah, and then obviously the antenna. These plugs, there's 2 holes in it. This always plugs into the left side. One on the right side, NCE makes what's called a cab 04 or a cab 06. All it is basically is that much from here up. And it's just got a little round throttle on it. It's for simply controlling trains only, or running trains, I should say. That plugs into the right side. So you can have 2 operators on the same system, so that I can control my train to stop and start it, you can control yours and stop and start it, if we're working at opposite ends or whatever like that. And they don't interfere with each other. If I'm talking with this, I'm talking to that engine, you can't access it. And vice versa, I can't access your engine as long as your throttle is connected to it. So the thing is, and I'm getting a little carried away, I get enthusiastic about this stuff, but there's no limits to what you can do. It just goes, you can keep building on it. Again, that's one of the advantages of the NCE system, is you can get the basic system and you can build upon it. You can add that booster. They also have a 10 amp booster. Run 20 trains at the same time. And the other thing is, and we'll wrap it up here in just a minute, is besides running trains, the button right there says select accessory. You can get stationary decoders to hook up to the switches on the track. And you select, all right, that's switch 163. Hit that, 163, and then you can turn the switches in the track for the turnouts. You can turn lights on in buildings, have the train order signal at the station go up. Anything you want. If it's something that you can use the decoder, all the stationary decoder is, it's an interface between digital and analog of moving something, or turning something, running a relay or a latching relay or something to turn things on and off. So you're limited only by your imagination. And we'll have another class where we talk about a little further into that with all the programming, changing volume levels of locomotives and adjusting the steam rate and such like that. Just go back real quickly. I know we gotta end it up here. I'll talk all day. DCC, if It's an easy conversion. If you don't think into it too much, it's easy to do. If you buy locomotives right out of the box, this thing here, that brand new out of the box. You set it on the track, this is brand new, you plug it in, you can run the train. There's no programming. A lot of the systems, like this is a Digitrack system, there's the command base, there's the power supply, there's this throttle, all these cables in between, and none of that with this. The only thing you have to do with all this down here is if you get a second locomotive, get it set up an address for it. So you can do as little as you want with it, or as much as you want. You got one locomotive, you're good to go. You can have trains up and running in 5 minutes or less at home. Beyond that, it's a matter of interest and study. The NCE throttle comes with this whole book with all the different programming. If you want to read, educated with that. These Calmback books are excellent. I'll be honest with you, that's where I've got most of my knowledge, is such as it is, about DCC. You can go online to the NMRA, and they have a section on DCC, talking about it. That's NMRA's DCC site. And this is now digital command control from Wikipedia. The information is out there, depending upon how much you want to look and how much you want to read. But the information is out there. These books are great as far as covering everything. How are we doing, Kurt?
We're doing fine.
Okay.
So I don't know if anybody need to take a break. If you wanted to keep going.
Have I bored you all to tears yet?
Good.
Want to keep going? I was starting to wrap it up here. I don't even know what time it is.
Almost 11:30.
Almost 11:30.
Gosh, I can't talk. Let's just pause then. Questions? Yes.
Your plug-in at the end, or where you put the throttle in, if you put one at the other end, do you need a local net connection?
Yeah, there's got to be a hard connection between the two.
Okay.
If you're using tethered throttles, obviously.
Right.
And they make another panel that's got the right connection and the right wire. This center plug right here is called the command bus. And you get a, that's a six wire connector. That'll run over, daisy chain over to another one. So you can hook up several. But the thing is still, when you pull the plug out of here, the train's gonna stop. If you want it to be able to pull the plug out and go down and plug it in over there, you've got to have that SB5. Because every DCC system has got several components. A throttle, a command base, and a power supply. Now, with NCE, they put the command station and the throttle all in one piece. Makes it a whole lot easier. Reduces the wiring, all the cabling and such like that.
But it limits you sometimes.
It-
Pull it out
yeah.
and you did.
When you go to that SB5, that's actually a command base. Separating it like that, then you're able to pull the plug. This is then just a throttle.
But all of your programming still goes through.
All your programming still goes through here, correct?
Yeah.
And the thing is, doing it this way also, you can use this throttle. I've been punching buttons when I wasn't looking here. No, that's not good. Because the way they built this system, you know, it's a 2 amp system. You go to the 5 amp, you don't have to change anything with this, because the power doesn't really go through here. You put the 10 amp system, you still use the same throttle. Other systems, you got to get a different throttle to go with the higher amperage for more trains. I'm sorry, let's go back to question. I know you had a question about that. Did I answer that for you on this?
Yeah.
That, I was told that clip, even though it looks like a telephone wire, don't try and use telephone wire.
No, well, this one here, from the throttle to there, that's a 6 wire connector. It's, I think that's what
But
they...
it looks like a clip for a
Oh, yeah,
telephone.
it looks like a
You could probably put it
telephone
in
clip,
there
yeah.
too, yeah.
Yeah.
But you can't use that wire.
The other side that goes to the auxiliary throttle, that's a 4 wire. The reason this is 6, it's got 2 power lines to come up here to power this up. Because There's no batteries or anything in this. Well, I think there is a battery, but it very seldom ever goes dead. And so you've got to be very particular to use the right cable. In fact, I found a six-wire cable the other day. I tried replacing this with the one that wasn't NCE. It wouldn't work. I don't know why, but you got to use the parts that they provide for it to work. The universality of decoders and throttles, you know, any throttle run any decoder, that's true. But you can't mix components of manufacturers like cables and throttles and power supplies. If you're going to go NCE, use just NCE equipment. If you're going to go Digitrax, use just Digitrax. But any of them will run any decoders.
The speakers in the locomotives, are they integral to the board, the motherboard?
No, they're generally this is an MRC, this is an older sound decoder. This is what they call a drop-in. You can see the terminals along the edges. And I think I forget what this was for. This is for an Athearn MP15. The Athearn, it's got a board in here with a couple of diodes and everything for the lighting, for the DC engine. You take that board out, you drop this one in, and then solder those 4 connections. They say drop in. I always thought that meant you drop it and run. You drop it in and then solder it. There's a little plug right there. This plugs in here, and there's your speaker. Now, speakers come in all sizes and shapes. N-scale, Wayne can tell you, it can be problematic sometimes, but they're making speakers smaller and smaller all the time that have got incredible sound. HO,
Say it's got to be hard on an in-scale, decoder and a sound card and a speaker, everybody
it can be. I've got a locomotive up there right now, just came in yesterday from Atlas. It's an N-scale Alco switcher. About that long. And it's got sound in it. ESU Loc sound. And it sounds pretty good too. We'll fire it up there when I get my test track moved back over. Oh, why don't you go?
I have a question.
Yes, sir.
I have an acquaintance that keeps short notice decoders.
Mm-hmm.
Is there something he can put on his system to kind of catch that before it happens? I believe there is something that you can get as an add-on to put in. It's escaping me right now who makes it, that you wire onto the decoder. Was it Digitrax?
It may be. It's a, you know, there's the Stay Alive, which will keep the engine running in case of loss of power. It's a version of that.
I mean, is it just for the individual locomotive, or is it for the whole system?
I think that you can get it either way. Well, see, what I've heard is like the AR1 for a reverse loop, it detects a short and then snaps the polarity in the other direction so you can continue on. It's a variation on that. It detects the short circuit and it shuts the decoder board down from the power supply. Because it's just super quick in the way it reacts. I don't know exactly who it makes, I have heard of it though. And that would be per, well actually, like the AR1, you could use it for the whole layout, depending on the size of the layout.
All right.
What is the Broadway Limited Rolling Thunder sound system?
All right, Broadway Limited, their sound system is called Paragon 2. They've had Paragon 2 locomotives for some time. I don't wait till these guys come back. I guess
Take a break.
yeah. We'll say turn the camera.